Hello viewers, welcome to my channel. I'm Hasham. So last video I have completed two problems on analysis of variance, Anova. It's a statistical technique, sampling technique where more than two samples are compared. When we want to compare the mean of more than two samples, we apply analysis of variance. So what is the procedure of analysis of variance? Already two problems I have completed in the last video. So if you want the complete perfection, watch the first video on theory of Anova, then second video on this two problems. Go to the playlist of my channel, select the subject statistics for management. Select the video of analysis of variance. Be perfect on the procedure. Now third problem I am going to start. But before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. So always keep it ready. Take a screenshot of the solution of the problem, then I'll explain each and every point. Come on, see the problem number 3. 3 salespersons account for the following amount of sales. So we are comparing the sales conducted by 3 salespersons. Sales in 1000 rupees. Test for the significant difference in their performance. In the problem, it will not at all be specified that it is a problem of Anova. You have to identify. How to identify? If 3 or more than 3 samples are to be compared, we have to apply Anova. Here 3 samples are given. Salesperson X, Y, Z. 3 salespersons are there. The sales conducted by them are given. Monthly sales in thousands rupees. X is the salesperson. He has conducted 48,000 in the first month. Second month 49,000. Third month 50,000. Fourth month 49,000. Similarly, Y is another salesperson. He has conducted the sales 47, 49, 48, 48. Z, the third salesperson. First month 49,000, second month 51, then 50, 50. So we have to find out whether the average sales of the 3 salesperson are significantly different or same. That's what we have to find out, right? So first of all, we can take the actual values which are given in the problem, or we can use coding method. If we take actual values, whatever is given in the problem, the calculations will be more because individual values are 48, 49, 50. Like this, we have to square the values, then we have to add up the values. So time consuming because the values are large values. So there's another simple method. We can apply the simple method to reduce the time, to reduce the calculation. That method is called coding method. So what is the coding method? A single constant will be deducted from all the given variables. The data will get reduced. The constant may be the average of all the values. So here you can see the values are 48, 49, 50, 49, 51, 50. So all the values are surrounding 50. Some values are above 50, some values are below 50, but on an average, the average value is 50. So we'll take a decision, coding method we apply. Subtracting 50 from all the elements. Then we proceed to calculate. The value of F will not be affected. Whether you apply coding method or if you do not apply coding method, your answer will be same. The advantage of coding method is our time will get reduced. Our efforts will get reduced. Calculations will be reduced. If we take actual values, same values, we have to square it. 48 square, 49 square, 51 square. Like that we have to make use of calculator. So otherwise, if we deduct a constant value from all the values will get reduced. So easily we can make the calculations. So here I am applying coding method. To simplify the calculations, we use coding method. So what is coding method? We subtract 50 from all the sample values. Randomly I have taken 50 because 50 is the average. If you see the problem, some values are above 50, some values are just below 50. So all the values are surrounding 50. So I am directing subtract 50 from all the sample values. The F ratio will not get affected by using this coding method. Ultimate answer will remain same. Now calculations for Anova. Salespersons are X, Y, Z. For X, 2 columns I have opened, X1, X1 square. For Y salesperson, 2 column, X2, X2 square. For Z, 2 columns, X3, X3 square. As usual, what we have done in the last 2 problems, right? Now, the values given for X are 48. So 48 minus 50 will get minus 2. Here I have taken minus 2. Second value is 49. 49 minus 50 will get minus 1. Here I have taken minus 1. Third value is 50. 50 minus 50, 0. Last one is 49. 49 minus 50, minus 1. This is minus 1. So I have subtracted 50 from all the X values. Similarly, I subtract 50 from Y values. The Y values are 47. 47 minus 50, minus 3. Right? Then next one is 49. 49 minus 50, minus 1. Then 48 minus 50, 48 minus 50, minus 2, minus 2. Minus 2, minus 2. Last Z. 49. 49 minus 50, minus 1. Here you can see minus 1. The next one is 51. 51 minus 50, it is 1. Then last two is 50, 50. 50 minus 50, 0. 0. That's it. This is called coding method. Now the values have become very simple. Easily, without using the calculator, we can find out the total. 2 square, 4. 1 square, 1. 0 square, 0. 1 square, 1. So total is 6. Without calculator, 4, 5, 6 directly we are using. Our ultimate answer will remain same. Similarly, minus 2, minus 1, minus 4, minus 1, minus 4. So 3 3s are 9, 1 1s are 1, 2 2s are 4, 2 2s are 4. Total 18. This total minus 8. Minus 1 plus 1, 0. So 0 is the total. 1 plus 1, 2. That's it. From here onwards, the procedure is same. What we have done in the last 2 problems. The sum of items in all the samples. Sum of all the items in the samples. T. Summation x1 plus summation x2 plus summation x3. Here's x1. Minus 4, minus 8, 0. So minus 4 plus minus 8, minus 12 plus 0, same minus 12. So t is equal to minus 12. Now correction factor CF is equal to t whole square by n. So minus 12 whole square divided by 12. N is equal to 12. Number of items in all the samples. First sample we have 4 values. Second sample 4 values. Third sample 4 values. 4 3s are 12. So totally 12 values we have in all the samples. N is equal to 12. So correction factor we got CF 12. 2 steps completed. Third step, the total sum of squares of all the items. Total sum of squares of all the items. That is called SST. Right? So SST is equal to summation x1 square plus summation x2 square plus summation x3 square minus correction factor. So x1 square यहाँ पर है 6 plus 18 plus 2. 6 plus 18 plus 2 minus 12. 6 plus 18 plus 2 minus 12. 14. SST we got. Now SSC. Sum of squares between the samples. Columns. Samples we have in columns. The samples are X salesperson, Y salesperson, Z salesperson. These are the 3 person sales are given. So sum of squares between samples, columns. The formula is SSC is equal to summation x1 whole square by n1. Summation x2 whole square by n2. Summation x3 whole square by n3 minus CF. What is summation x1? Minus 4. So minus 4 whole square divided by n1. N1 means how many items are there? 4 items are there in every sample. So n1 is equal to 4, n2 is equal to 4, n3 is equal to 4. So minus 4 whole square divided by 4, you will get 4. Minus 8 whole square divided by 4, you will get 16. 0 square by 4 is 0. Minus 12. So SSC we got 8. We got SST, we got SSC. Now we want SSE. Sum of squares within the samples, that is called error. SSE is equal to SST minus SSC. So 14 minus 8, 6. That's all the calculations required for Anova table completed. Now null hypothesis. mu1 is equal to mu2 is equal to mu3. There is no significant difference in the performance of the three salesperson. The average sales conducted by all the salespersons are same. No difference. Null. Alternative hypothesis, yes. The performance of the three salespersons are significantly different. The average of all the three salespersons are different. That is alternative hypothesis. Now, table, Anova table, exactly same. 5 columns. First, source of variation. Second, sum of squares, degree of freedom, mean squares, F ratio. Variance ratio or F ratio, anything you can see. First of all, between samples, columns. Between samples means columns. SSC. How much SSC we got? 8. Degree of freedom, C minus 1. How many columns we have? 3 columns. 3 minus 1, 2. MSC is equal to SSC by degree of freedom, 8 divided by 2 is 4. Similarly, within samples or error, SSE. SSE we got 6 here. Then degree of freedom, N minus C. N means total number of items. 12 items are there. 12 minus 3, 9. MSE is equal to SSE divided by degree of freedom. 6 divided by 9, 0.67. Now we can find out F ratio. MSC divided by MSE. So MSC is 4. 4 divided by 0.67, that comes to around 6. So 6 is the computed value of F. Now we proceed. Level of significance 0.05. Nothing is given, so I have assumed 0.05. Degree of freedom. The numerator degree of freedom is V1 and denominator degree of freedom is V2. The numerator is MSC. For MSC, what is the degree of freedom here? 2. Denominator is MSE. MSE degree of freedom is 9. So V1 is equal to 2 and V2 is equal. Here you can see V1 is 2, V2 is equal to 9. V1 degree of freedom for numerator 2, degree of freedom for denominator 9. Now critical region. The table value of F at 5% level for V1 is equal to 2 and V2 is equal to 9 is 4.26. I told you. We have to refer the F table. I have provided this F table as a PDF in the description. You can take a printout of this PDF of F table and keep it ready. Without this, we cannot give the conclusion. So here PDF for this F table, we have 1% and 5%. Now we are having 5% level of significance. So 5% points you see there. V1 degree of freedom for numerator, that is V1. V1 is 2 and V2 is 9. So for under 2 and against 9, we are having 4.26. You can see the table. Under 2 and against 9, we are having 4.26. So 4.26 is the critical value. So any value which is more than 4.26 will fall in rejection region. And any value less than 4.26 will fall in acceptance region. So here diagrammatically I have shown here right side, because we are having positive values. Positive values always will go on right side. So this 4.26 is the critical value. Our computed value is 6. So 6 is greater than 4.26. So 6 is falling in the rejection region. When it falls in rejection region, the null hypothesis is rejected. What null hypothesis? No significant difference in the performance of the three salesperson. That we have rejected. So what we have accepted? Alternative. In alternative hypothesis, we have specified that the performance of the three salesmen are significantly different. The average sales conducted by three salesperson are different. That will accept it. So here the computed value of F6 is more than the critical value 4.26, so it falls in rejection region. Null hypothesis is rejected and we conclude there is significant difference in the performance of the three salesperson. That's all. So this is the end of problem number 3. Come on, now we'll start the next problem. Problem number 4. So far 3 problems we have completed. Fourth one. To test the significance of the variation of the retail prices of commodity in three principal cities, Mumbai, Kolkata and Delhi, 4 shops were chosen at random in each city and the prices observed in rupees were as follows. So here the researcher wants to compare the retail prices in the 3 cities. The 3 cities are Mumbai, Kolkata and Delhi. So 4 shops are randomly selected in each city and we have recorded the prices prevailing in the 4 shops. So the cities are Mumbai 16, 8, 12, 14. These are the prices in 4 shops in Mumbai. In Kolkata the prices are 14, 10, 10, 6. In Delhi the prices are 4, 10, 8, 8. Do the data indicate that the prices in the 3 cities are significantly different? Do this data show that the prices are significantly different in the 3 cities? So null hypothesis, no significant difference, the prices are same in all the 3 cities. Alternative hypothesis, yes, the prices are significantly different in all the 3 cities. Now we proceed to calculate for Anova. Calculations for Anova retail prices Mumbai, Kolkata, Delhi. X1, X1 square, X2, X2 square, X3, X3 square. First you take the screenshot, then I'll explain all the points. Come on. See now. X1, X1 square, X2, X2 square, X3, X3 square. Right? As usual we have done. The prices are given in Mumbai. Mumbai prices are 16, 8, 12, 14. Same to same. Whatever is given in the problem. The total comes to 50. Now square it. 16 square, 256. 8, 8 is 64. 12, 12, 144. 14 into 14, 196. Take the total 660. Similarly, take down the values of Kolkata. Kolkata the prices are 14, 10, 10, 6. Square it. Then we got the total. Delhi the prices are 4, 10, 8, 8. These are the prices given in the problem. Take the total 30. Square it. 245. We have prepared the table. We got all the total values. Now step by step. Same steps what we have done in the last 3 problems. Now the sum of all items in all samples. The total of all items in all the samples, that is T. So T is equal to summation x1 plus summation x2 plus summation x3. Here x1 is 50, x2 is 40 and x3 is 30. So 50 plus 40 plus 30, 120. T is 120. Now we find the correction factor CF. T whole square divided by n. So 120 whole square divided by n. N stands for total number of items in all the samples. Every sample we are having 4 items. In Mumbai 4 items, in Kolkata 4 items, in Delhi 4 items. So 4 3s are 12. So totally 12 items are there. So n is equal to 12. So 1200 is the correction factor. Now the total sum of squares of all the items in all samples, SST. We have to calculate SST. The total sum of squares. The total sum of squares of all the items in all the samples. The formula SST, summation x1 square plus summation x2 square plus summation x3 square minus CF. x1 square is 660. x2 square 432. x3 square 244. 660 plus 432 plus 244 minus correction factor 1200. So you can see SST comes to 136. Now we calculate the sum of squares between samples or columns. Samples are given in columns. So sum of squares between samples, column SSC. Summation x1 whole square by n1 plus summation x2 whole square by n2 plus summation x3 whole square by n3 minus CF. So x1 is how much? 50. So 50 square divided by 4. 40 square divided by 4, 30 square divided by 4 minus 1200. Now you simplify SSC 50. So we got SST, we got SSC. Now SSE, sum of squares within the sample, it is called error. So SSE is equal to SST minus SSC. So SST is 136 minus 50, we'll get 86, SSE. All the calculations completed. With the help of this, we can make the Anova table. This is the Anova table. Same 5 columns. First, source of variation, sum of squares, degree of freedom, mean squares and F ratio, variance ratio. First of all, between samples, columns, SSC. How much is the SSC here? 50. Degree of freedom, C minus 1. You have to remember this because first video, second video, I have explained you the table, Anova table. The degree of freedom for columns is C minus 1. How many columns we have? 3 columns, 3 samples. So 3 minus 1, 2. MSC is equal to SSC divided by degree of freedom, 50 divided by 2, 25. That's it. Now within samples, error, SSE. How much SSE we got? 86. Then degree of freedom is N minus C. N stands for total number of items in all the samples. That is 12. Already we have calculated 12. So 12 minus 3 is 9. Then MSE is equal to SSE divided by degree of freedom. 86 divided by 9, 9.56. The total is SST 136. If you add up 50 plus 86, 136. And N minus 1 is the degree of freedom. 12 minus 1, 11. So 2 plus 9, 11 for our verification. Now, F ratio. F is equal to MSC divided by MSE. So 25 divided by 9.56 will get 2.62. This is the computed value of F. The main purpose of making this table is to find out the computed value of F. Now, null hypothesis. Mu1 is equal to mu2 is equal to mu3. There is no significant difference in the prices in the 3 cities. Alternative hypothesis, mu1 not equal to mu2, not equal to mu3. There is significant difference in the prices of the 3 cities. The prices are significantly different. This is the alternative one. Level of significance, nothing is given, we assume 0.05. Now, degree of freedom. Degree of freedom, we need 2. Degree of freedom for numerator, degree of freedom for denominator. Here, numerator is MSC. For MSC, what is the degree of freedom here? 2. So, V1 is equal to 2. And denominator, we are having MSE. So, MSE, what is the degree of freedom? 9. So, V2 is equal to 9. Now, in the table, I have given this table in the description, a PDF of T table. Take a printout. Here, 2 values are there, 1% points and 5% points. We are concerned with 5% level of significance. So, 5% points, you see V1 is 2 and V2 is 9. So, column 2 and row 9, you will find 4.26. So, 4.26 is the critical value of T. So, any value which is more than 4.26 will fall in rejection region. And any value which is less than 4.26 will fall in acceptance region. So, 4.26. This is the critical region or rejection region. Shaded region is the rejection. Unshaded region is the acceptance. Now, we'll see our computed value will fall where. The computed value is 2.62. So 2.62 is less than 4.26. This is the 4.26. So 2.62 will lie somewhere here. 2.62. Now easily we can see 2.62 is less than 4.26. It falls in acceptance region. When it falls in acceptance region, we accept the null hypothesis. This null hypothesis we are accepting. What is null hypothesis? There is no significant difference in the retail prices in the 3 cities. So ultimately decision. The computed value of F 2.62 is less than the critical value 4.26. So it falls in acceptance region. Null hypothesis accepted. There is no significant difference between the retail prices in the 3 cities. That's it. This is Anova. Remember, only listening the lecture, watching the video is not enough. Statistics require your practice. If you watch the video, only if you watch the video and listen the lecture, only 50% of your preparation is over. Remaining 50% depends on your practice. After watching the video, close the video, take this problem sheet and do the problem yourself, whether you are getting or not. If you are stuck at any point, again go back to the video and see what is the correct procedure. In that way only you can get the perfection on the problems. Inshallah, we'll continue the next problem in the next video.